let's do an example that uses the chain rule. So this is what the chain rule says. The derivative of a composition of functions. So the chain rule is for taking the derivative of compositions. So it says the derivative of the composition f of g of x equals f prime of g of x times g prime of x. So in words, that's essentially saying the derivative of the composition equals the derivative of the outside function evaluated at the inside function times the derivative of the inside function. So the problem I'm wanting to do here is the derivative of the sine of x to the fifth plus 5x squared plus 8. So we know how to take sine of x, and we know how to take polynomials, both of those things by themselves, but since they're combined in a composition in this function, we need to use the chain rule to take the derivative. Okay, so let me write out what it is for you. Okay, so my rule says that I want to start by taking the derivative of the outer function. So in this case, my outer function is sine. And the derivative of sine of x is cosine. Okay, so I'm going to have cosine evaluated at the inner function. Okay, so basically cosine, and then I keep what's inside the same. So cosine of x to the fifth plus 5x squared plus 8. And then I multiply that by the derivative of the inner function. My inner function in this case is this polynomial x to the fifth plus 5x squared plus 8. So the derivative of that is 5x to the fourth plus 10x. Alright, so this is my derivative using the chain rule. Now let's find the derivative of e to the tangent of x. Once again, I'm going to have to use a chain rule on this problem because it's a composition of functions. I know how to take the derivative of e to the x, and I know how to take the derivative of tangent of x, but when I combine those things in a composition, it takes a chain rule to find the derivative. So I've written the chain rule underneath here once again to reference. So the derivative of the composition is the derivative of the outside evaluated at the inside function times the derivative of the inside function. Okay, so in this case, my outer function is e to the x, and then my inner function is tangent. So if I actually go ahead and evaluate this derivative, okay, the derivative of the outer function, e to the x, is just e to the x. So that part's going to stay the same. And I'm evaluating it at the inner function. So I'm just going to keep my e to the tangent of x. But the chain rule part of this says that I need to multiply by the derivative of that inner function. So I need to multiply by the derivative of the tangent. And the derivative of the tangent is secant squared. Alright, so my answer is e to the tangent of x times secant squared of x. Let's do one more chain rule problem. This one's going to be a little bit trickier. So we've got the derivative of the cosine of e to the 7x squared. And then once again, I have the chain rule written down below for us to reference. So let's go ahead and get started on this one. So to use a chain rule, I want to think about what my outer function is and what my inner function is. So here I have the cosine of e to the 7x squared. So my outer function is cosine, and my inner function is e to the 7x squared. So the chain rule says that I want to start by taking the derivative of the outer function. And the derivative of cosine is negative sine. So I have negative sine, and I keep the inner function. So it's still evaluated at e to the 7x squared. But the chain rule part says that now I need to multiply by the derivative of the inner function. So I need to multiply by the derivative of e to the 7x squared. But e to the 7x squared is also a composition of functions. It's not just e to the x, which would be quite simple to take the derivative of, but rather it's e to the 7x squared. So I need to use the chain rule on that part. So this is actually a double chain rule problem. But let's separate it into two steps. So if I back up just a step, what I've done so far is I've taken the derivative of the outside, and I have that inner function still in there, and now I'm going to multiply by the derivative of the inside. So for now, I'm just going to write times the derivative of e to the 7x squared. Okay? So let's now just concentrate on that new derivative we want to take. So when you have a double chain rule problem like this, try not to think about too many things at once. Just think about one derivative at a time. So I'm just going to keep this negative sign out front, but I'm just going to forget about it for now. And all I'm going to do is I'm going to just focus on taking the derivative of e to the 7x squared. Okay, now to take the derivative of e to the 7x squared, I'm going to use the chain rule. So here my outer function is e, the exponential function. And the derivative of e to the x is just itself. So this part's going to stay the same. E to the 7x squared is just going to stay the same. But because of the chain rule, I need to multiply by the derivative of the inner function. And the inner function in this case is 7x squared. So the derivative of 7x squared is 14x. Okay. So let's clean this up a little bit. Now we've actually finished the problem. And there are different ways you could arrange this. I'm going to write it as negative sign of e to the 7x squared. So that e is inside the sign. And then times 14x e to the 7x squared. So once again, when you're doing these double chain rule problems, don't let it confuse you. Just think about one step of the problem at a time.